In this video, we will explore list comprehensions in more detail. Mainly, we will be seeing how to use if conditions in list comprehensions and how to use nested list comprehensions. So this is what we did in our last lecture. So we basically had a list and we created a new list in which we took the power of 2 for each element in the first list. So this was the output for those for both of those lists, which were obviously same. One was created using the loop and the other one was created using the list comprehension. So now let's say we want to do the same thing, but there's one difference, that we only want to take power for those elements which are, let's say, less than 5, right? So we don't want to take power of all the elements. We will be only taking the power of those elements which are less than 5. So those will include 2, 4, 3 and 1, because 12 is less than 5. So if I want to do it in this for loop, what I will do here is I will add a condition and I will say if item less than 5, only then append into the list, otherwise not. So if I run this code now, see, so this the first list which is being created using this loop does not contain the value 144, which is a power of 2 for 12, and 12 is greater than 5, so it did not include the power for 12. So we want to do the same thing with list comprehension. So the syntax is very simple. At the end, like after the loop, you can write your condition. So we will use the same statement which we used in the for loop here. So we will write if, and then we will put our condition, which is same like item less than 5. So now this code or this item will only be added if this condition is passed. So let's run this code and see what it does. See, so now it does not include 144 because for each iteration it first ran this check, and if it was true, only then it added this element, this whole statement into the list. So for when it found 12, this condition was false for 12, so it did not add this element in the list. So now we will see how to use nested list comprehensions. So let's say we have a matrix which you must have studied in your mathematics subject. So a matrix will look something like this. So let's say I have these elements at each row, 2, 3, 4, and then I have 19, 3, 21, and then at the third row I have 4, 1, 2, -4, right? So first I will explain this. So this is basically a list, and inside this list we have multiple items. This is one item, this is second, and this is third item. So for at each item, the item itself is also a list. So you know, a list can contain lists itself. So this is basically called nested list. So this represents one row of the matrix. This is the second row, this is the third row. So what we want to do is we want another list, which I will call flat matrix, and it will contain all the elements of this list, but of this matrix, but those elements will be at the same level. They won't be at the different levels of rows like in this element in this list. So basically the output should be something like this. So it will contain all the elements from each row of the matrix, but this itself will be only a single flat list and not a nested list. So this list has been converted into this list. So this is basically what I want to achieve. So if I want to do it with the for loop, so what I will do is I will have a nested loop, and I will say for row in matrix. So what it will give me here is at each iteration it will pick one element from this list, and that element will be the whole list. So I want to iterate over that nested list. So I will have another loop here. So that will be, I will say column in row. So now this row itself is a list, so I can iterate over it like we do on simple list. So now this column will contain each element from this row. So first it will have initially this row will contain this list, and then when this loop will run, this row will have this, and this column will have first element of this row, which will be 2. Then it will run again, it will have 3, it will run again, it will have 4, and then it will exit, and the outer loop will continue, and the outer loop will pick the next element from this list, which will be this, and this will keep on going until it iterates through the whole list. So now I will have another list which I will call flat matrix, and it will be initially empty. And what I want to do is I want to add this item here in this list, right? So I will say flat matrix dot append, and I will just add column here, which will be each item here in all these nested lists. So now if I print flat matrix, let's see what it has. So now it has the matrix, but it is flattened. So all the elements are at one level and there is no nested list. So now if we want to do the same thing with the list comprehensions, I can also achieve that. So for that, like you know that list comprehension will return a list. So we will create a variable which will contain the outer output list when the list comprehension will finish. And now inside this list comprehension, like we saw before, that we can write for statement here. So this is the for statement, and now because this is the nested list comprehension, we will write another for statement here, which will behave as the nested for loop, just as in this case. So now the nested one will be same as we use in the nested for loop, so which I will write after the outer loop. So now this basically is same as this one. So this is the outer loop and this is the inner loop. So for each item at in this matrix, this loop will run. So this will achieve the same behavior as this one. So now what we want to do is we want to write the element here, which we know will be added in the list. So what will be that element? So that element will be the column value. Like we saw here that we appended the column value in our new list. So now we will write column here, and we know whatever we write here at the start of the list comprehension, that element will be added in the output list. So now after it will finish running, this column will have all the elements from these nested lists, and those values will be added in a list, and that list will be given as output of this statement, which we will store here in flat matrix. So now if I comment out this code and now I print flat matrix, the results should be same. So see, now it is giving us the same result. It has flattened the matrix, but the result were achieved using the list comprehension. So this is it about list comprehensions. I have added a link in the description below, which I would suggest you go and read, and where you can see more examples of list comprehension to improve your understanding of the list comprehension. See you in the next video.